This is the first episode in the series for Test and Improve Your Intelligence. These innovative ideas in problem solving are not only important for professionals and managers who are working for industry and business, but also useful for everyone in their day-to-day life. Your brain is an incredible piece of machinery. About the size of a squished softball, it contains billions of cells. And these cells can make more connections than all of the phones in the world. It's such huge network that produces your brain power. Would you like to feel the brainnet in action? And would you like to test your intelligence of your brain? Well, I would like to present one problem, one challenging puzzle that really tests your intelligence levels and also the massive potential what your brain has got. Well, please look at the diagram which I am going to draw and show it to you, a network diagram with nodes and branches. Your job is to figure out how many different routes are there from starting point to the finishing point that can take you across the network, of course without repetition. But here are the few rules. One is that you should only move to the right in the network diagram when counting the routes, but you cannot come back. And if you reach any junction place, you can either take the top route or the bottom route. Now start counting. In recent years, using network flow models has become a very popular management science technique for a couple of important reasons. First, a network is drawn as a diagram which literally provides a complete picture of the system that is under analysis. This enables a manager to visually interpret the entire system, and thus it enhances his level of understanding. Second, large number of real-life systems can be modeled as networks that are relatively very easy to conceive and construct. So for these reasons, using network flow models in decision-making process in industry sector has become very popular. We come across these network flow models for computer science and mechanical engineering students in different subjects like operations research, management science, operations management, network optimization, and in project management. Therefore, even from the academics point of view, gaining critical insights on network flow models will be very important for engineering students. In general, the network flow models are used to analyze three different types of problems in network optimization. They are shortest route problems, the minimal spanning tree problems, and the maximal flow problems. And in project management, we use techniques like PERT and CPM, which are extensively used in projects analysis. Now I am going to draw the network diagram which is given in the problem. These are the nodes in the network diagram represented by circles. I am using scribble technology on iPad to draw accurate geometric figures. Very useful technology for demonstrating concepts in engineering education for the teachers. So these are the nodes given in the network diagram, network problem. Now again I am using scribble technology to connect these nodes with branches that are straight lines. As already said, this scribble technology by Apple is very convenient and useful for all teachers in the education sector. So these are the branches represented by straight lines that will connect these nodes in the given network diagram. So there are 16 nodes, the given problem in the network diagram, that were connected by these branches that are straight lines. Well, this is the network diagram, and this is the starting point, starting node, and this is the finishing node, finish point. Now, as per the problem, we'll have to figure out how many different routes are there from start to finish in this network diagram, and of course without repetition, and with those two rules given in the given problem. That is, you should only move to the right in the network diagram, but you should never come back. And whenever you reach a junction, either you can take the top route or the bottom route. So with these following conditions, you have to figure out how many different routes are there from starting to finishing point in this given network diagram. Of course, there are many ways to do this. One is to count it manually. For example, one can start from here, travel like this, and travel like this to reach the finishing point. We can say the route number 1. And for example, one more route can be travel like this. You can go like this, you can take a turn, you can reach this, and you can also reach the finishing point as, let us say, route number 2. And one more route can be, for example, you can start from here, turn like this, go like this, turn like this, go like this, and reach again the finishing point as route number 3. So even you can start from here, travel like this, and reach this finishing point as route number 4. And even you can travel like this, go like this, go like this, and reach the finishing point as route number 5. So like this, there are different routes that are available, and you can start counting them manually like this. But the problem is, there is more confusing way and less accurate. It's why? Because this looks little manageable when there are only 16 nodes in the given diagram. Suppose if there is a problem with, let us say, 32 nodes, or let us say 64, then counting them manually is going to be extremely difficult, and of course the accuracy is always questionable. Therefore, we need to look at more intuitional way to arrive at the answer, to arrive at the solution for this problem with less confusion. So my idea of presenting this problem is to present such an intuitional technique that gives more very accurate answer, but with less confusion. Now I'm going to remove all these explanatory routes that I have drawn manually for better explanation and for better understanding for you. So this is the network diagram with start and finish. Fine. I would like to present the intuitional technique like this. It goes by a simple logic. For example, if there is a node A with the two preceding nodes B and C, preceding nodes. Then the number of routes available to reach the node A in this small network diagram with the two preceding nodes B and C is always equivalent to the number of routes available to reach B plus the number of routes that are available to reach C. Simply A equal to B plus C. That is, if there are two routes available to reach B and there are three routes that are available to reach C, then the number of routes available to reach the node A in this diagram is just equivalent to 5, 2 plus 3. The whole intuitional approach of solving this problem, it goes by this simple logic. The number of routes available to reach any node in a network diagram is simply the sum of the number of routes available for its preceding nodes in the given network diagram. If suppose there is one more node D which is a preceding node for A with, let us say, 4 routes available, 4, then the number of routes available to reach A is always equivalent to 2 plus 3 plus 4 is equal to 9. If there are n nodes in the given network diagram, then the number of routes that are available to reach A is always equivalent to the number of routes available for B plus number of routes available for C plus D plus so on up to n nodes. You can solve this problem even by manually counting the number of routes from starting point to the finishing point. But this is more confusing way. Therefore, we have to use an intuitional way to count the number of routes available from the starting point to the finishing point, but with less confusion and with more accuracy. I would like to present such intuitional technique that can give you a 100% accurate answer at the end of the problem with less confusing way. So this is the idea of presenting this problem. Now let us take the network diagram with the starting and finishing nodes as it was displayed. Now we'll take the first node in the network diagram and initialize it as 1 always, meaning that the starting node has got one route available to reach it. If not, this problem has got no meaning. So initialize the starting node with number of routes available to reach it as 1. Now take the next node in the network diagram. It will also have only one route to reach since it has got only one preceding node with one route available. And even this node has got only one route to reach, and even this node has got only one route to reach based on the same logic. Similarly, if you take this node, this also has got only one route, and this node has got only one route, and this node has got only one route to reach based on the same logic. So for all these nodes there are only one route that's available to reach them. But if you take this node, so it has got two preceding nodes. Therefore, the number of routes available to reach this node will be 1 plus 1, which is equal to 2. So this is 1 and this is 1, two preceding nodes. Now we will take this node. It has got two preceding nodes with one root available and with two roots available. So the number of roots available for this node equal to 1 plus 2, that's equal to 3. So conclude as 3. Now if you take this node with the same logic, this node has got two preceding nodes with 2 plus 1, so that is also equal to 3 roots available. So conclude it. Now you take this node which has got two preceding nodes, so with 1 plus 3 roots, which is equal to 4. So conclude this one as 4. Now if you take this node, it has got 3 plus 3, so total number of roots available to reach this node equal to 6. With the same logic, if you take this node, this has got 3 plus 1 roots, which are equivalent to 4 roots available. So conclude as 4. Now if you take this node, this has got 4 plus 6, which is equal to 10 roots available, and this node has got 6 plus 4, which is equal to 10 roots available. And finally, if you take the finishing node, so this has got 10 plus 10, which is equivalent to 20 roots. So conclude the problem as 20 roots available. So the total number of roots that are available from starting point to finishing point are equivalent to 20 without repetition, and by following those two given rules, like we can only move to the right in the network diagram, but we should never come back. And whenever we reach a junction place, we can take either a top route or a bottom route. So this is how we can approach this problem with an intuition skill. So this is going to be a less confusing way and more accurate. It's not more accurate, exactly accurate as per the given conditions. Finally, these are the problems for self-practice. So based on the innovative ideas and critical insights you have gained so far with our previous discussions, I would like to suggest you to extend your thinking on the following two problems to further improve your innovation capabilities. The first problem is a network with 25 nodes. So apply the same innovative idea to arrive at the exact solution for this network. Now second problem, how do you feel about the network with 36 nodes? So these two problems would extend your innovation capabilities in terms of application of new knowledge what you have gained so far.